the Siemens PLM components, Parasolid in particular, and JT, and D-Cubed really have a major, very major presence in the market.
Hello and welcome to our discussion with Ken Versprille at SimData, who recently authored a white paper about Siemens PLM components. I'm your host, Margarita Pariente, and today I'll be asking Ken how leading technologies like Parasolid and JT empower the next generation of 3D engineering software solutions. Before we start, Ken, could you introduce yourself to the audience and say a few words about your work with SimData?
I'm probably most famous in the CAD world because my PhD dissertation was non-uniform rational B-splines, which has been called now NURBS. And I've been now with SimData almost 12 years, doing basically the same kind of consulting where I work with both solution providers and industrial clients on their use of CAD.
Thanks for joining us, Ken. We are very happy to have you with us. Let's get started. I'd like to begin by asking, what interested or surprised you most about PLM component business when you were researching your white paper?
It was interesting to me to see where geometric kernels, specifically Parasolid, was being used. Your first glance is you would think in CAD modeling, but it turns out that very often Parasolid was used in simulation, some of the simulation applications, some of the machining applications. JT, I sort of already knew. I had been looking at collaboration for the last 15, 20 years and the different solutions to do collaboration. And I knew JT was right up there in its use, especially in automotive.
Can you talk about some of the challenges that software vendors face when developing new applications and how solutions like PLM components help them to meet those challenges?
So time to market is very important. If they had to implement all the technology in their application, that could take months, possibly even years. So components give them a head start. Over the years, it's become more and more apparent that industrial users want quality software. They can't afford to deal with problems in the software to try to overcome them. They are expecting good quality. Is the component software provider innovating? Or are they sitting there stagnant, just trying to rest on their laurels of what they currently have? Are they adding to the product? The fourth area would be data interoperability. How difficult is it to get data into the component and get data out of the component so it can be shared with other applications, other tools that they're using?
So my next question is, as part of your research for the white paper, SimData assessed the market penetration of PLM components in various PLM sectors. Could you elaborate on the results of that research?
SimData publishes every year what are called the marketing numbers, the sales from the different industrial solution providers. So we can see how much CAD is being sold, where is it being sold, in what country, how much simulation software is being sold, where, in what countries, in what regions, in what areas. The problem is to look at component software, the solution providers do not publish those numbers. So what we chose to do was simply take a look at what were the market numbers of the products that contained a particular component software. And it turned out the results of that is by far the Siemens PLM components, Parasolid in particular, and JT, and D-Cubed really have a major, very major presence in the market based on those kinds of numbers.
Great to hear that. Your white paper includes a chapter about innovation in our industry, which is clearly important to software vendors who need to keep pace with industry trends. What were your findings about Siemens sharing its innovation through component technology with other software vendors?
Well, I think that specifically what was being called out in the research was the work that had been done in Parasolid to deal with facet meshes and lattices. With the big push towards additive manufacturing that's happening across the industry and in all the different verticals, lattices provide a way of reducing weight, reducing use of materials. So that became very important. And what we saw coming out of Parasolid, keeping pace with that level of technology, was very important to end users. The other area was Inkineo, the component to handle robotic simulation and robotic controls. That was very, very well appreciated by a lot of the end users.
I often get asked why Siemens openly licenses PLM components to potential competitors when it could keep the technology in-house and create some competitive advantage. What kind of benefits do you see for a software vendor like Siemens choosing to being open?
Well, when it comes down to it, I think any reasonable person in this industry will agree it is a heterogeneous world. No one vendor can provide everything or keep up with the trends everywhere. You need to play in a multi-solution provider environment. By keeping, as Siemens does, an open environment on their own tools, they play perfectly into that kind of mindset, that kind of technology positioning. And it's well appreciated by other end users, by the other vendors who want to complement some of the Siemens tools.
Well, thanks again, Ken, for joining us today and sharing your insight into the PLM components business.
Thank you for the opportunity to speak with you and your users.